The purpose of the ignition system is to provide enough electrical voltage to discharge a spark between the electrodes of the spark plug. And the second one is to provide the spark at exactly the right time to ignite the highly compressed air-fuel mixture in the combustion chamber of the engine. In other words, we need to provide enough voltage to provide a spark at exactly the right time so that the air-fuel mixture will start on fire at exactly the right time. Typically, in a small engine, enough electrical voltage is about 10,000 volts, and the right time is just before top dead center when the piston is coming up on the compression stroke. The principles of electronics start with the three measurements or elements of electricity. The first one is current. And when we take current, we're always going to connect another word to it, and that is the word flow. Current is a measure of the flow of electricity in a circuit. The flow is what does the work. If you don't have current flowing, nothing will happen. The next word we're going to talk about, next principle here, is the voltage. The voltage is a measure of electrical pressure. So we want to connect voltage and pressure. We always have pressure. Just like at the tap of water in our kitchen, you always have pressure at the tap. You don't have flow until you open up the tap, but you always have pressure. Voltage is a measurement of the pressure. And the last one is resistance. A resistance is a measure of the amount of the opposition to flow in a circuit. So an example of this would be if you had put your finger over the end of a garden hose while water is coming out of it. You can see that as you put out opposition to the flow, that changes the amount of current or the amount of water flowing through it. So we've got flow, pressure, and opposition to flow. Another principle of electronics has to do with magnetism, and magnetism is the force where objects are attracted or repelled in relation to one another. So we have two magnets with a north and a south pole, and they will pull together and be attracted to one another. And north will push away, and south will push away. Faraday's law is another one. Is the voltage induced into the circuit is directly related to the number of coils in the circuit. To demonstrate this, I'm going to draw a wire here, a wiring diagram, and in this wiring diagram we have a battery, and then we have a circuit. And that circuit goes over here like this. Okay, and off the positive we could go to something we call a fuse and a switch. And this will go down to a light bulb and reconnect here. So anytime we turn this switch on, which will open that up so that current could flow through the bulb, we have current flowing through the wire all the way around. And when we have current flowing through the wire, you don't see it, but there is a magnetic field around that wire. The more current flowing through, the greater the magnetic field. So if we go back to Faraday's law, the voltage induced into the circuit is directly related to the number of coils in the circuit. So when we have different coils in a circuit, the amount of voltage induced is directly related to how many coils we have. If we have a lot of coils, we get a lot of voltage. Another principle of the ignition system is induction. I already used the word induced, and that comes from this word induction. Induction is when an electrical current is transferred from a magnet to a coil of wires, or from one coil of wires to another coil of wires. So if we look at our picture here, you can see, we'll just get rid of some of this, And instead of just a plain wire in between here, we're going to draw a bunch of coils of wire like this. And so as current is flowing through that wire, there's a magnetic field formed around that wire. So that magnetic field is formed around this coil of wire. You got a big magnetic field there. If we take another wire and we put a coil of wire through there like that, that means that because it cuts through the magnetic field in this area, current then starts to flow and voltage is induced or transferred from this circuit into this circuit, and current starts to flow. We have current flow right there. Even though these two circuits aren't actually touching, current voltage is induced into the other side and current starts to flow. So if we go back to our definition here, it says when an electrical current is transferred from a magnet to a coil of wires, or from one coil of wires to another coil of wires, that in effect is a transformer. It uses induction to increase voltage and decrease current. And the way that it increases the voltage has to do with the number of windings in the wires. The more windings there is in this set of wires, the greater the voltage there will be, and that allows us to jump across the spark plug. Here are the components of the magneto-ignition system. We'll start over here on this side. We have the flywheel magnets, and then the flywheel magnets, this is the flywheel itself. And the flywheel magnets are a part of the flywheel, and you can see as the flywheel turns, the magnet will come around to this magneto-coil at exactly the right time. You can see we have this coil right in here, so we have a series of inner coils. Those are called the primary windings. And we have a series of outer coils. That's over here, and they go all the way around like that. And those are the secondary windings. The whole unit is called an armature. And you can see that these red lines here, that's a magnetic field. We have something called points right here, and a condenser to make sure spark doesn't jump across the points. And we have an air gap, which is our spark plug up here on top. So that's the air gap right there.